This instructional video will focus on the mathematical concept of chance, more commonly known as probability. Probability is a mathematical measurement that is applied to events. In other words, it is the assigned value given to the likelihood of a particular outcome occurring in a random situation. Probability can be calculated by forming a part-whole fraction, where the numerator represents the number of times an outcome can occur, and the denominator represents the total number of possible outcomes.
For example, I have 6 M&Ms, 3 are red, 2 are blue, and 1 is orange. I want to find out the probability of selecting a red M&M. So, the total number of possible times I could select a red would be 3. This is the numerator. Now, the total number of possible outcomes, that is, all my M&Ms, is 6. This is the denominator. So the probability of selecting a red M&M is 3 in 6.
This is what we call theoretical probability, because we have all the information that we need to calculate the expected probability for each possible outcome.
Given the symmetry of a fair die, for example, in which there are only 6 possible outcomes, there is no reason to assume that one outcome is more or less likely than another. This is a random event, so theoretical probability depends on our understanding of the sample space.
The Stage 2 syllabus for New South Wales requires students to be able to describe and compare chance events in social and experimental contexts. Students should conduct chance experiments, identify and describe possible outcomes, recognise variation in results, and make statements that acknowledge randomness.
Let's see what this might look like in a classroom.
Students are investigating the probability of the spinner landing on blue on an equally coloured spinner, such as this one. We can all see that the probability of this event occurring is 1 in 5. However, investigations such as this can often highlight student misconceptions.
Students may think that because a particular outcome has recently occurred, it has a high probability of reoccurring. For example, the spinner may land on red 5 times in a row, leading students to predict that the next outcome will also be red. If the investigation were to stop here, the results of this small data sample could lead students to believe that the probability of spinning blue is 0 in 5.
Calculating the theoretical probability for an event sets up an expectation for a particular set of results. For example, that the spinner has an equal chance of landing on all colours. But in reality, we often see variation within the results, caused by randomness.
A way we can help our students to understand randomness is by providing them with experiences using a range of data sets. This can be done by students pulling together short-run data that they have collected in smaller groups.
By compiling and comparing the results across the whole class, students are able to see variations and begin to understand the concept of randomness.
Other student misconceptions may include assuming probability based on lucky or favourite numbers or colour, and human influence and control such as force of a particular spin or throw of a die.
The most effective ways to help students reconcile these misconceptions is through a range of different experiences incorporating multiple representations.
We hope that you found this instructional video helpful. Thanks for watching!